So let's have our first problem. A rescue team moves 70 meter 30 degree west of south, followed by 50 meter 40 degree east of south, and finally 30 meter 25 degree west of south 100 meter east. Now the first question here is calculate the resultant displacement, and the second question here is calculate the distance traveled. So first we need to write the table wherein we're gonna have like here the 70 meter and then 30 degree west of north, and then followed by 50 meters 40 degree east of south, then finally 30 meter 25 degree west of south, and next 100 meters east. And so the first thing that we need to do is to identify the proper angles or the standard angle given with the reference angle coming from the x-axis. So we're going to write here proper or standard angle, the standard angle that we're using in math. And so from here we can see the directions. We have here the east is 0 degree, and then the north is 90 degree, west is 180 degree, and the south is 270 degree. So let's have now our proper angle or the standard angle. We have first here the 30 degree west of north, and so that means from north going to west, that is 30 degree. And since we have here from the north that is 90, so we can see here that okay, from 0 then 90 plus 30, that would be 120 degree. So that is the proper angle. Next is we have the 40 degree east of south. That means from south, which is from 270 degree, add another 40 degree. That is 270 plus 430, that would be 310 degrees. And then next one is 30 meter 25 degree west of south. So from south going here 25 degree, and so we can say that is 270 minus 25, that is 245 degrees. And the other one is 100 meters east, and so 100 meters east is starting from 0 degree, so we could have the proper angle here, which is 0 degrees. And so we can calculate now for the x component and the y component of each vectors. So first we're going to write here the x component, and we all know that the formula for x component is actually cosine. And so what we could do here is we could have 70 multiplied to cosine of 120 degrees, and if you're gonna press that in your calculator, that will be equal to negative 35. And then followed by here we have 50 multiplied to cosine of 310 degree, and that will gonna be 32.1. And the other one is 30 multiplied to cosine of 245 degrees, and we're gonna have negative 12.7. And next one is 100 multiplied to cosine of 0 degree, and we all know that the cosine of 0 is 1, and so this one will become 100. Now let me remove this first for us to have a space for y component. So for the y component, we have again choose 70 multiplied to sine of 120 degrees. So we will just replace it, and that is, if you press your calculator, that is 60.6. And then we have here 50 multiplied to sine of 310 degrees, and that is negative 38.3, followed by 30 multiplied to sine of 245 degrees. And notice that this is negative 27.2, and 100 multiplied to sine of 0 degree, and sine 0 is 0, and therefore this one is 0, 0. Okay, And so the next thing that we're gonna do is to find the summation of all our x component and the summation of all of our y component. Since we are using r, we could have here the sum of all our resultant, okay, vectors. And so we have here the rx. So instead of f, we will use rx, and the sum here is 84.4, and the sum of the ry is equals to negative 4.9. And so take note that the units of all of this is meters. And so what is now a resultant vector? We have a formula here, which is we're going to use the Pythagorean theorem. We're going to have the r sub x, the summation of the r sub x square, plus the summation of all of our r sub y square, and plugging in, we could have the square root of 84.4 square plus negative 4.9 square. Okay, and pressing that in our calculator, we're gonna have around 84.5 meters in its decimal, in 1 decimal place. Now, how about our direction? Now, how about for our direction? This time, we'll have our formula, which is the angle arctan over summation of ry over summation of rx. So if we're going to apply the formula, we're going to have arctan, and that is negative 4.9 all over 84.4. And if we're going to press that in our calculator, it will going to give negative 3.3 degrees. Now take note, if you press your calculator, what you are getting here is the reference angle. Now, since we have on our data, the summation of ry is negative 4.9, so we can expect that this is the negative, somehow this is the negative 4.9, and the rx is 84.4. So we are thinking now that the angle is negative 3.3, and that it means that this one, the angle, is, the reference angle is from east going 3.3 degree below. And so we could say, of course, 3.3, so this is negative 3.3, that means negative 3.3 south of east. And so our formal angle, translating it from, if we're going to translate it in a proper angle, that is from here up to here, right? So somewhere here. So if we have a proper angle, that will gonna be around 356.7. That is 360 minus 356, 360 degree minus 3.3 degree. That is 356.7. So degree, or we could say, okay, 356.7 degrees north of east. Okay, and so what will now be our angle or our final answer? The final answer here is calculate the displacement, that is 84.5 meters at 3.3 degree or 3.3 degree south of east, or 356.7 degree. If it is like a proper math, you could say 356.7 degree, and you may want to add up north of east. Now, how about another question here? This one is very easy. calculate the distance traveled. So for the distance, we don't care about the direction. So it's very simple to add up. And that would mean we're just gonna have, okay, we'll have 70 plus 50 plus 30 plus 100, and that will gonna result to 250 meters. Since distance is a scalar quantity, direction is not required. And that's it for this problem.